We are going to go over the quiz from 10.4 through 10.6. So if you don't have that, go grab it. And if you haven't already looked at the comments that I left, please pause the video, go find those comments so you can see how I graded the quiz, because I'm going to want you to go over your quiz and decide if you agree with the grade that I gave you, okay? So pause the video and get that stuff ready if you don't already have it ready. Alright, so 1a, this problem is worth 2 points, and we have the cubed root of x times the fourth root of x to the third, and we want to simplify using the rules of exponents. So we want to change these to fractional exponents, and then with the rules of exponents here, we're going to add these together. So I need a common denominator, which is 12. So I'll multiply the top and bottom of this by 4, top and bottom of that by 9, and I get x to the 13/12. Now this is a perfectly good answer right here. We could also write this as 13/12 is 1 plus 1/12 and split it up like that, and then x times x to the 1/12, which is x 12th root of x. So I would accept this answer as well. Alright, 1b, we're going to simplify the fifth root of x to the fourth over the square root of x. We're going to do the same thing. We're going to change to fractional exponent. So I didn't really go over that over here, so let's just take a second and go over that real quick. When you change to a fractional exponent, this exponent becomes the numerator, and then the index, which is written here, becomes the denominator, and that's how you change a radical to a fractional exponent. So this is to the first power, so that's going to be a 1 on the top, and when the index isn't written, it's a 2. So now the rules of exponents tell me that when I have this situation, I subtract the exponents. Again, I need a common denominator, so I'll multiply top and bottom by 2 here, 5 here. Subtract, I get 3/10. So this is a perfectly good answer, x to the 3/10. If you want to change it back to radical form, you'd have the 10th root of x to the third. Now 3/10 is less than 1, so I didn't have to do this step of splitting up. 13/12 is bigger than 1. So I wanted to change that to from a improper fraction to a mixed number and then simplify it. And this is worth 2 points as well. Alright, c is also worth 2 points, and we have the cubed root of the fourth root of x to the third. Alright, so let's start with this inside part here. And we're going to change that to a fractional exponent. What would the fractional exponent for that be? X to the 3/4. Okay, so now we have that, and that's still underneath a cube root. I'll take an extra step. That's still underneath a cubed root. So now I want to take this cubed root and write that as a fractional exponent. So I have x to the 3/4, and then that's going to be to the 1/3. Alright, so now the rules of exponents tell me I'm going to multiply those together. So these 3's will cancel when I multiply 3/4 times 1/3. Here, I'll just write it out here. 3/4 times 1/3. Those 3's are going to cancel. I have x to the fourth, which is the fourth root of x. I'd accept either of these answers here. Alright, let's move on to number 2. We're going to simplify by adding, subtracting, multiplying, or dividing. Those are our directions here. And this guy is worth 2 points. So I have two radicals here that are not like terms. So I want to see if I can add these together or subtract these in this case, and I can only do that when these are the same, which they're not. So I need to see if I can simplify. There's multiple ways to do this with the 72. We're looking for a perfect square that goes into 72. If we do 36 times 2, that's going to be the fastest way, but we could also do 9 times 8. And you'll get to the same answer. So let me do the fastest way over here, and then I'll show the 9 times 8 way. So if I do 36 times 2, then I can split this up, and that gives me 6 square roots of 2. Now if I would have done the 9 times 8 and split it up this way, I'd have 3 radical 8. But then I could break 8 down some more to 4 times 2. So then I have 3 times the square root of 4, which is 2 radical 2, which also gives me 6 radical 2. So either way you do it, you're going to get to 6 radical 2. This way is just a little bit longer. Now for the 18, a perfect square that goes into 18 is 9, which is 9 times 2. So if I split this up, square root of 9 is 3. 2 stays in there. 6 radical 2, take away 3 radical 2 is 3 radical 2, not a minus, 3 radical 2, combining like terms. All right, 2b is also worth 2 points. And we are going to FOIL this guy because we have a binomial times a binomial. All right, so 5 times 3 is 15. And then 5 times root 7 is 5 root 7. And then we're going to do root 7 times 3 and root 7 times root 7. So root 7 times 3, negative root 7 times 3 is minus 3 root 7. And then a negative root 7 times a positive root 7 is negative square root 49, which you could write, but it's just going to come out to be 7. Root 7 times root 7 is 7. So here we have like terms. We can combine those together. 5 root 7 take away 3 root 7 is 2 root 7. And then here I have minus 7. Now I can do my 15 take away 7, which is 8, and put those together and end up with this binomial right here. Question number 3 is about rationalizing the denominator, which means making it so there's no radicals in the denominator. A is only worth 1 point. There's pretty straightforward here. When you just have one term in the denominator, you multiply the top and bottom by that term, and we're going to get 7 root 3 over root 9, which is just 3. And that's it. That's rationalized because the denominator doesn't have a radical in it anymore. The next one has a binomial in the denominator. So in order to get rid of the radical in the denominator when there's a binomial, you have to multiply the top and bottom by the conjugate. 3 plus root 2. So for the numerator, we can just distribute the 5 into the binomial. And for the denominator, we're going to have to FOIL this out. Right? So let's do the numerator first. So 5 times 3 is 15. 5 times root 2 is 5 root 2. So in the denominator, we're going to have 3 times 3, which is 9. 3 times root 2, which is positive 3 root 2. Negative root 2 times 3, which is minus 3 root 2. And negative root 2 times positive root 2, which is negative root 4, which is just 2. So when you multiply by the conjugate, you're always going to get this situation where the radicals drop out, sort of like difference of squares. So in the top we have 15 plus 5 root 2, and in the bottom we have 7. We've rationalized the denominator because there are no more radicals in the denominator. So now we get to some solving stuff here. So 4a is worth 2 points, and we're solving. And we have radical x minus 5 minus 4 equals negative 1. So to get rid of this radical so we can get x by itself, we're going to have to square both sides. But we really want to isolate the radical first. We've got to move this 4 out of the way to make squaring both sides easier. So now if I square both sides, the square root and the squared are going to undo each other, and I'll just be left with x minus 5. And then on this side, I'll square the 3 and get 9. Now I'm pretty much home free here. Add 5 to both sides, and I get x equals 14. Now with any radical equation, you want to check your answer. So let's go ahead and check our answer. So we're going to plug 14 in for x here and get 14 minus 5, and then simplify it out. So 14 minus 5 is 9. The square root of 9 is 3. Take away 4, and we do get negative 1. So that checks out. That is our solution. 4b is worth 3 points. And here we have x minus 5 equals radical x plus 1. So we have the radical by itself on one side of the equation. So we can go ahead and square both sides. Now on the left-hand side, we have a binomial squared, so we do have to remember to multiply that out, or write it out twice, so we can FOIL it out. On the right-hand side, it's going to be pretty easy. The squared and the square root are just going to cancel each other out. On the left-hand side, we have to FOIL, so we get x squared minus 5x minus 5x plus 25 equals x plus 1. Now hopefully you recognize that you have a squared in this equation, and you have terms that are just x's. This means you're going to have to set the equation equal to 0 and either factor it or use the quadratic formula. Let's see what happens here. So we have negative 5x, and negative 1x. That's going to be negative 11x. And 25 take away 1 is positive 24. So to see if it factors, we have to see if there's any factors of 24 that will add to be negative 11. And it looks like negative 8 and negative 3 will do it. So we're not going to have to use the quadratic formula, although you could. If you use the quadratic formula, that's fine. If we factor it and set each factor equal to 0, then we're going to get our two answers of 8 and 3, which should be the same things you get if you use the quadratic formula. Now, we do have to check our answer. So let's check. We have x minus 5 equals square root of x plus 1. So we're going to erase these x's and we're going to put in our answer. So let's first check x equals 8. So we'll put 8 in here and see what happens. So 8 minus 5 is 3, and 8 plus 1 is 9, and the square root of that is 3. So that checks out. 8's an answer. Alright, let's check x equals 3 and see what happens. So if x equals 3, put that in for my x's. I get 3 minus 5 is negative 2, and 3 plus 1 is 4, and the square root of 4 is positive 2. These are not equal, so that means that 3 is not an answer, and the only answer is 8. So we always have to check when we're dealing with radicals. Question number 5 tells us that x equals 1 plus radical 3 is a solution to this quadratic equation. And on part A, it says to show that x plus radical 3 is a solution of the equation by substituting 1 plus square root 3 in for x and showing the left-hand side simplifies to the right-hand side. All right, so basically we're doing the checking part, kind of like we did here, where we take a solution and we plug it in and we see if it works. So we're going to take 1 plus radical 3 and we're going to put it in for these x's here and do the simplifying and see if it comes out to be 0. All right, so instead of x, I'm going to write 1 plus radical 3 squared minus 2 times, and then instead of x, I'm going to write 1 plus radical 3 minus 2 equals 0. If 1 plus radical 3 is a solution to this equation, then the left-hand side should come out to be 0 when we simplify it. So here we have a binomial squared, which means we need to write it out twice and FOIL it. For a 2 times a binomial, we can just distribute that in there. So we get negative 2 minus 2 radical 3, and we'll just bring down this minus 2. All right, let's do this FOILing here. So we have 1 times 1 is 1. 1 times radical 3 is radical 3. Radical 3 times 1 is radical 3. Radical 3 times radical 3 is radical 9, which is just 3. And we'll bring the rest of this stuff down. All right, let's combine like terms and see what we get. Let's do our radicals. All right, so we have 1 radical 3 plus 1 radical 3, that's 2 radical 3. Take away 2 radical 3 is 0. And then normally I wouldn't write it, but we're just going to write it here for the sake of clarity. And then for my constant terms, I have 1 plus 3, that's 4. Take away 2, take away 2, that is going to be 0 as well. So I get 0 equals 0, which shows me anytime you get the left-hand side to equal the right-hand side, then you know that you have a solution to the equation. So part B, which is worth 2 points, says to show that x equals 1 plus radical 3 is a solution to the equation by actually doing the quadratic formula. Actually solving it. So let's go ahead and solve x squared minus 2x minus 2 equals 0 using the quadratic formula. So we have a equals 1, b equals negative 2, and c equals negative 2, a, b, c. And our quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And when we simplify this out, we're hoping to get an answer of 1 plus radical 3. Now you should know that you're going to get two answers. Can you think about what the other answer should be? One of the answers is 1 plus radical 3. What should the other one be? Alright, so I have the opposite of b. Be careful here because b is negative 2, so we have the opposite of negative 2. That's going to end up being a positive. Plus or minus the square root of b squared. Also be careful here, especially if you're using your calculator. B is negative. If you don't put this in you shouldn't have to use your calculator for this because you know what 2 squared is. But if you were to put this in your calculator without the parentheses, it would not square the negative and you'd get a wrong answer. Alright, so then we have 4 times a times c all over 2 times a. Alright, let's do this out. We'll go this way. So I get the opposite of negative 2, which is positive 2. Negative 2 squared is 4. Watch your negatives here. You have a minus and a negative, so that's going to end up being a plus. 4 times 1 times 2 is 8. All over 2. Alright, so now we have 2 plus or minus 4 plus 8 is 12 over 2. Now 12 we can break up to 4 times 2. Or excuse me, 4 times 3. Higher mathematics there. 4 times 3 over 2. And we can take the square root of 4, which is going to be 2. And when we take the square root of 4 and 2, it's going to go right here in front of the radical. So we're going to have 2 plus or minus, and then this square root of 4 is 2 is going to go right there. The 3 stays under the radical, all divided by 2. So now I have two terms in the numerator, and I need to divide each of those terms by 2. So 2 divided by 2 is 1. 2 root 3 divided by 2 is 1 root 3, which I won't write the 1, so I get this for my answer here. X equals plus or minus 1 plus or minus root 3. So certainly 1 plus root 3 is an answer, and the other answer is 1 minus root 3. Alright, I hope that helps going over the quiz. If you have questions on any of these, please let me know. Feel free to rewind the video and look at any of these problems again.